All right, here we have a problem where it deals with um, multiple types of energy, potential energy and kinetic energy specifically. And we want to solve for the first one, we want to solve for the gravitational potential energy, the change potential energy of the block and the bullet. So here what happened is that the bullet hits a stationary block and the block starts to move upwards. Okay, so that's the whole problem that we have here. In order for us to solve this, we just want to compute for the change in potential energy of the object. So that's delta GPE equals to mgh. Okay, the m would be the combined mass of the block and the bullet. The g would be the acceleration due to gravity, and the h would be the change in height of the wooden block as they move together. So this gives you 602 times 9.8. Actually, let's just use SI. So that's 602 times 9.8 multiplied by 0.086. Okay, 0.602 multiplied by 9.8 multiplied by 0.086. That gives you 0.51. So the change in potential energy is around 0.51, given that it lifts up at around 8.6 centimeters. Now, here we want to prove that the initial speed of the block and the bullet after they begun to move off together was 1.3 meter per second. Now, problems like this that only deals with mass and GPE, usually what we do is we try to not combine but work together the GPE and KE. So what I do here is that I'm going to lead with GPE gain equals to KE loss. Okay, so GPE gain equals to KE loss. Now you don't need to really identify which switch, but we just need to put the equation. So this is MGH, and this one is 1 half mv squared. Cancel the mass. Then what you are left with is GH, the half, and v squared. So since we're trying to find out v, make v as the subject of your equation. That gives you v squared equals to 2gh. Square root both sides, and you will have your equation, square root of 2gh. Now solve for the v, square root of 2 times 9.8 times 0.086. So let's try to solve that. 2 times 9.8 times 0.086, and you'll get 1.29 or 1.3. V is equals to 1.3 meters per second. So this is confirmed. Okay. Now let's move on with the last two questions. Here, you are asked to use the information at AII and the principle of conservation of momentum determine the speed of the bullet before the impact with the block. So here we're going to use conservation of momentum as we have discussed it already, so it should not be any problem. At first, the only motion that you have is the bullet. The block is stationary, so that gives you V times 0.002 equals to 0.602 multiplied by 1.3. Right? That's the speed of the block and bullet. This is momentum before, this is momentum after they hit each other. So 0.602 multiplied by 1.3 and you get 0.78. 78, this is V, divide it by 0.002. Okay, 0.78 divided by, and you will have V equals to 390 meter per second. Makes sense. Bullet moves very fast. All right, and the last one is that we want to find out the kinetic energy as before the bullet hits the block, before the impact. So that gives you KE. equals to 1 half mv squared. Use the speed that you've solved earlier. 1 half times 0.002 times 390 squared. Square this times 0.002 divided by 2. So, the total kinetic energy is 152 joules. This is how you solve this problem.